In this video, I want us to discuss through some of the questions that I gave to my students. And this is IAL International Advanced Level AS Physics, and we shall have a revision on mechanics and materials. So in this section, we were discussing with my student that if an object is dropped in a fluid, there are different forces which are involved. For instance, the object will be moving down, so it will experience drag, which is acting upwards as the object is moving down. And then we have another force which acts upward, which is upthrust force. Upthrust force. So if an object is moving at terminal velocity, you need to understand that terminal velocity is the constant velocity attained by an object, constant maximum constant velocity which is attained by an object when it's moving through a fluid. And condition for an object to attain terminal velocity is whereby this object is going to be experience equal upward forces and equal downward forces. So the weight will be balancing with upthrust and drag force. And now on that regard, we will need to understand also that upthrust force is equivalent to the weight of the fluid displaced. Now, for instance, if in the event we have an object, we have this object here being immersed in a liquid. If we have this object immersed in a liquid, or if we put this object in a liquid, then this object is going to displace volume of water. The amount of water it's going to displace is equivalent to the volume of the object. So that means that if you know the weight of the liquid displaced, that will be equivalent to the upthrust force this object is going to do what? To experience. Now, for you to work out the mass of the liquid, remember density equals to mass over volume, and then mass will be density times volume. Then the weight will be the density of the liquid times the volume of the liquid displaced times the gravitational force, G, which is 9.81. So upthrust equals the weight of the liquid displaced. So that is exactly what you ought to know at that given point. Now let's move down and talk about a little bit on projectile motions. And if an object is projected at an angle of 53 degrees, that is at a velocity of 37 meters per second, something that you ought to realize that in this projectile motion, there will be upward forces and horizontal forces. So you are going to resolve into vertical forces and you shall resolve in the horizontal direction. The vertical component is going to enable you work out maximum height, time taken to reach maximum height, and as well we can be able to work out the maximum height reached. But the horizontal component in that case will enable us work out the range and time taken to land on the other side. So remember that a vertical component are usually affected by gravity, but horizontal components are not. So that's why you can see if we want to work out the range, we just take the horizontal component, which is 37 cos 53 times the time it takes to times the time of flight. Time of flight is time taken to travel through time it remain in air before landing. So if you want to work out time of flight, you will first calculate time taken to reach maximum height. Time taken to reach maximum height. And remember, at maximum height, final velocity is 0. That is final velocity in the component, the vertical component. In the vertical component will be 0. And then if you get the time taken to reach maximum height times 2 will give you the time the object took to travel through this trajectory. Now in that case, now calculate the horizontal distance traveled by the ball before returning to the height it was hit from. So first, we are supposed to work out, resolve the horizontal component and that vertical component. And then now we have the vertical component as that 7 sine 53. Acceleration, we shall use negative 9.81 because this object is moving upwards. If an object is moving upward, is going against gravity, and the object will be decelerating. So the acceleration of the object will be negative because the object will be slowing down. Then the vertical final velocity in the vertical direction will be zero. At this point, it will be zero because the object will become momentarily at rest at the highest point. And then we need to work out time. Time will be equals to what? So V equals to U plus AT, and then if you work it out, you are going to get 3.0125. And the horizontal distance in this case is going to be, we are going to use the horizontal component, yeah, which that 7 equals 53 times 6.02. Because we had gotten time to reach maximum height was in this case 3.012, then we are going to multiply by 2 because time to reach maximum height is the same time to take to come down to this position. So total time will be 6.02. And then if you work out that, you're going to get 134.1 meters. That's another question that you can be asked, and other question that you can be asked in A-level physics, year 12 AS physics, is a question to do with vectors. And in that case, what we can do, we need to represent the displacement. Which of the following could represent the final displacement? Now, if we translate this vector, the concept I used, if we have a vector at this point going that direction, so in that case, let me just remove this. If we have a vector pointing this direction at this point, then we want to shift that vector so that we can join it to this other vector at this point here, so that we can be able to draw a parallelogram. So we shall have a parallelogram joining this way, and then now the resultant vector becomes the diagonal of the parallelogram that we have obtained, and the resultant vector will be acting in that direction. And if we can look at the option that is giving us, that is actually B. So the boy was throwing a ball towards a wall, and the wall was 5.0 meters from the boy. The top of the wall was 3 meters above the point where the boy released the ball. So we can see the height that we are talking about is this height here. And then in one attempt, the boy threw the ball with initial velocity of 9.7 and at an angle of 49 degrees to the horizontal. This is the angle. So we can be able to state that the vertical component is 9.7 sine 49, yeah, and the horizontal component is 9.7 cos 49. This is 9.7 sine 49 for the vertical component, and horizontal component is that. Now show that the ball traveled distance of all about 0.8. So meaning that we are going to use the horizontal component and the time given in order to work out the range. And or we can even decide to use the range that is provided here and the time that is given in order to check whether and the horizontal component, we're going to use the distance given and the horizontal component and check whether we are going to get the same time, because the range is the initial velocity in the x direction times time. Then we're going to say that will be 5 divided by the horizontal component, which is going to give us 0.8, and then that is correct. Deduce whether or not the ball went over the wall in one attempt. So in that way, what we shall do, we shall use the time that we have gotten in this case here, and then try to check how high was the ball by that particular time. And in that case, we have initial velocity in the vertical direction at this time is 0.97 seconds and acceleration is negative 9.81. We're using acceleration negative because the object was moving up, so it will be decelerating, it will be slowing down. And we can now apply the equations of motion at this point, and we shall get the displacement in that case is going to be basically less than that. So it did not go off over the. So basically that's some of the questions that you'll be asked in AS physics. Make sure at least you are able to follow through, and subscribe for more content because more videos will be added on the same regard.